Hello everybody and welcome to Work Against the Grain. My name is Jeff. A little bit different video for you today. Legacy CNC Woodworking, and I'll put a link in the description, did a really nice tutorial on this valentine box. And it's a heart-shaped box, as you can see, and then the lids come together like this and snap onto the box, and you've got your name and your wife's name or your significant other, and it just produces a really neat looking box to store little trinkets or jewelry or whatever the case may be in. And so I took that idea because I love boxes, whether it be on the lathe or bandsaw boxes, and I said, you know, how can we make box making easy on the CNC machine? And so what I did was I took another piece of 3D clip art that I had, which was the marine dog, and I created a box out of the marine bulldog. And so you see there's the box that you can put stuff in, and then there's the marine bulldog, and that fits on there like that. Nice tight snug fit. And then you've got a really neat, and I have some sanding to do on this, but you've got a really neat little trinket box here, again for jewelry or coins or, you know, whatever you use a little box for, candy dish, whatever. So let me show you. Again, I'll put a link in the description as it relates to the Legacy CNC Woodworking Valentine's Day box. And then let me show you how we did this bulldog box. And then you can take the processes that were used to create these to create just about any shape or size of box that you'd like to make. So let's hop into Vectric and I'll show you how we did it. Okay, so here we are inside of Vectric, and let's go ahead and create a new file. And we're going to do the box bottom first. And so we'll select a material size of 12 by 12. We're going to make the box 1.5 inches thick, our 0 at the bottom, and let's go ahead for now and put our XY datum in the middle of the project and click OK. And now, since this is technically the bottom of the box that we're working on here, we really only need one layer and a couple of tool paths. And so I thought what we'd work on first is a buffalo box. And so here I have a piece of buffalo clip art. And so we'll bring that buffalo in and we'll center them in the center of the project. Then the next thing that we want to do, and now keep in mind this is our model that will ultimately be the top of the box. And now what we'd like to do is come to our modeling tab and let's put a vector boundary around the model. And so we'll click this icon here, and voila, we have a vector boundary that goes around the model. Now let's go ahead and turn our model off so that all we can see is just this particular vector. And then what we want to do, because this is a box, we need to hollow out the inside. And the hollowing out of the inside will not only be the hollow part that you put stuff in, but it will also be the hollow area in which the box lid will fit down into. And so we'll come to our drawing tab, we'll select the vector, and we'll offset that vector inwards by 3/8 of an inch, 0.375. And offset. Close. And so now, as you see here, this part in here will be the cutout for the box. It will be where the lid recesses down inside that pocket. And then this distance between this vector and this outer vector will be the space where, when you set the lid down on top of the box, that'll be the ledge that supports the lid. And so really, as far as the box bottom goes, we just need two quick tool paths here, which is a tool path that we can hollow out this center and a tool path that we can cut the bottom of the box out. And so let's start with the inside one. We need to do a pocketing tool path. Our material is 1.5 inches thick. We probably want at least 1/4 inch of material left on the bottom. And so we'll go 1.25 inches deep. We'll use a 1/4 inch end mill, and you can certainly use a larger end mill here, but one thing to be considerate of is that whatever end mill that you use to hollow this pocket is probably best to use when we do the lid, so that when the tool comes in these tight corners, it is the same whether it's on the lid or the bottom of the box. And I'll show you what I mean in just a moment. So we'll take the 1/4 inch, we'll do an offset tool path so it starts in the middle, works its way out, and let's call this pocket box bottom, and calculate. And then we need to cut the box out, and this shows where that tool path is going to go, and you can get that to turn on and off by this checkbox down here, the solid checkbox, so that you can see your tool path as a solid. Then we'll select the outer vector to cut it out. We'll do a profile tool path. This tool path we're also going to use 1/4 inch, but we need to go through the material. So we need to go at least 1.5. I go 1/1000th of an inch deeper. 1/4 inch end mill. We want to go outside the line. If you don't have a vacuum table, you will probably want to add tabs to the tool path. 1/4 inch in length. 3/8 of an inch in thickness. We'll go ahead and edit the tabs, and we'll click here, see the little check mark. We'll put a tab here, we'll put a tab here, and we'll put a tab here. Close, and we'll call this cut out box bottom, and calculate. It's letting you know it's going to cut all the way through the material. Click OK, and then let's preview all of our tool paths. And so as you can see, as I tilt this up, if you can imagine, much like the boxes I showed you earlier, you have the hollow of the box here, you have the ledge on which the top will sit, and then you have the box that is all cut out. And so now what we'll do is we will go File, Save As, and put this somewhere where you know the location, and I'm going to call it Buffalo Box Bottom, and save. And then we need to save both of our tool paths because they're both the same tool. On my machine, I can just select both of the tool paths and save them to a location that you know, Buffalo Box Bottom. My tool paths are called TAPs for my Cam Master machine, and save. So now I have saved my box bottom. I have saved my box bottom tool paths on my 1.5 inch material. And now what we're going to do is do the top of the box. So now we've saved our box bottom project and our box bottom tool paths that was all cut out of a piece of material 12 by 12 and 1.5 inches thick. Now, we'll stick with the 12 by 12, but we don't want necessarily to cut our top out of an 1.5 inch thick piece of material, right? We can probably do it with a 1 inch or even a 3/4 inch piece of material. So what I have found to be the easiest thing to do is, rather than try to keep track of everything within one project file, we have already saved this as the box bottom. And so now, without touching any of the vectors at all or the model itself, what I want to do is come up here and go File, Save As, and now let's save this as Buffalo Box Top instead of Buffalo Box Bottom, and click Save. My file for my box bottom has not changed, nor will it be affected by any of the edits that we make here, because as you look up here at the top, we are now working in what's called the Buffalo Box Top. So the second thing that I'll do is come over here and erase both of my tool paths, because these were tool paths for my 1.5 inch thick piece of material and for my other file. And then I'll come over here to the Drawing tab and change my material thickness to be 1 inch instead of 1.5 inches, and click OK. And so now I have a 1 inch piece of material with the same vectors that I use for the box bottom for my box top. Only now I'm going to do the model to make my box top. But because the box top is essentially two-sided machining, there's a couple of things that we need to do first. So let's go ahead and turn the model off, and let's set up our levels of our project. So right here we know that this level 1, not our levels, our layers. And so we know this layer 1 contains both the model and the vectors that outline the model as well as the inside. And so what we want to do is, to set these up, is we want to take both of these vectors, right click, copy to layer, new layer, and we're going to call this box top. Uncheck visible, uncheck active, click OK. Then we want to highlight them again, and we want to copy these to a new layer and call it underside of box top. Not visible, not active, click OK. And so now if you look in your layer tree, we're going to rename this one 3D model. Then we have a box top that is turned, or that we have turned on now and labeled box top. And we have the underside of the box, and now that's turned on. So the first thing that we're going to work on is we're going to turn off the 3D model, we're going to turn off the top, and we're going to work on the underside of the box. Now, because this is the underside, and just a couple points of housekeeping here, whatever layer you're working on, you want to be highlighted black. If it's highlighted red, it means in this case you have the underside that you're looking at because the light bulb's on, but you're working on the box top layer because it's red and it's saying, hey, you're working on me, but my light bulb's not on. And so you want to make sure that you're working on the layer that the light bulb is on. And so since this is the underside of the box top, we have to flip these vectors over. And so what we'll do is we're going to come here to our mirror tool. We're going to flip about the job center. We're not going to create a mirrored copy. And in this case, I'm going to go ahead and flip horizontal. And so now, if you can imagine, we turned the box top over. And now we're looking at the underside of the box top. And so what we have to do here is we have to build the tenon, the male portion, whatever you want to call it, that slips inside the hollow area of the box bottom that we created. And so we're going to take this vector here, which is the outline of the 3D model, and we're going to offset that outwards by 1/16 of an inch. And click Offset and close. And again, because this is the underside of the box top, we need to pocket out the area between this vector and this vector. And so we'll come over here and have those two highlighted. We will use a pocketing toolpath. We're going to pocket down 1/4 of an inch, and all of this is assuming that your material has been planed on both sides and it's 1 inch thick. We're going to pocket a cut depth of 1/4 inch with a 1/4 inch end mill, and we're going to call this underside pocket. Calculate. And so now when I preview my tool paths, you can see that this section here will now insert into the box. Then when we flip it over and machine the 3D model and cut out its profile, you'll have a really nice box top that fits on top of the bottom we did earlier. But before we can flip it over, we've got to have some indexing pins. And so what we'll do is we'll come here. I use 1/2 inch dowels. And we're going to, I usually go 10/1000ths of an inch over the diameter of the dowel. And we're going to put create a 1/2 inch diameter dowel locating hole on the workpiece so that we can use it to line up the workpiece when we flip it over. And so I'm going to put one right here, I'm going to put one right here, and I'm going to put one right here, so that when I flip this over, it can only go one way. And now click close. And so we need to pocket these out on the bottom of the material. And so rather than make another tool path, I'm going to reopen my underside pocket, and I'm going to hold down my shift key, select my dowel locating pins, and calculate. And now if I reset my preview and I preview the visible tool paths, I now have 3 locating holes and the underside all cut out. But in order for me to locate this onto my spoil board, I need to send these 3 holes to my box top. And so holding the shift key down, I'm going to select all 3, right click, copy to layer, box top. Now we are all done with the underside of our top. So I'm going to turn it off. I'm going to turn on my box top, and I'm going to make sure that all of my edits are being done on the box top by making sure box top is highlighted in black. Now you can see that my buffalo has been flipped over the other way, but if you recall, these holes here, if our material is flipped, they are now in the wrong position. So I'm going to mirror these horizontally, because that's the way I'm flipping the material, about job center, and flip. And so now I have 1 hole here, 1 hole here, and here, so that when I turn the material over, it's now lined up the same way as the holes are on the underside. So I'm going to make these 3 holes into my spoil board by creating a pocketing toolpath. I'm going to go into my spoil board 1/4 of an inch with a 1/4 inch end mill, and I'm going to call this spoil board after flip, and calculate. And so when you see on the CNC machine, reset my preview, when you see on the CNC machine, when we flip this material over, before we put the top of the box onto the machine, we're going to mill these 3 holes. And so now all that's left for me to do now is to turn my model back on, come back to my 3D model layer, and machine my buffalo, and then cut it out. So the first thing that we're going to do is a roughing toolpath. We're going to place the model. I like to typically give my my model the first 32nd of an inch or so of the material. I just like to make sure that my model is sitting below the top of the material so I get some nice detail, and click OK. And then I'm going to use the model boundary as my to tell the tool how far out to go. But I'm going to go 40 thousandths of an inch past the material boundary, and I'm going to leave 40 thousandths for my finishing pass, and I'm going to 3D raster along X, and I'm going to call it Buffalo Rough. With my 1/4 inch end mill, calculate. And then I'm going to do my 3D finish. I'm personally using a 3-degree taper ball nose. You can use whatever finishing toolpath you would like to. Once again, model boundary. This time I'm going to come only a 32nd of an inch past the boundary. I'm going to use an offset toolpath. No, I'll do a raster on X back and forth, and we'll call this Buffalo Finish, and calculate. And then all I have to do left is cut it all out. And so I'll select the outermost vector, choose a profile toolpath. We want to cut through the 1-inch piece of material. I go 1,000th of an inch deeper. 1/4 inch end mill outside the vector. We will add tabs again, edit the tabs. We'll put them in the same place that we did the box bottom. Close. And we'll call this cut out top and calculate. It's letting me know I'm cutting through the material. Click OK. And let's preview in order of the way that we're going to do it. So the first thing that we're going to do is put our material on the CNC machine, and we're going to cut this tool path, which is the underside pocket and our 2 indexing pins. Then let's reset that. We're going to pull the material off the machine and then machine these holes onto the spoil board. Then let's reset. We're going to now put our material back on the CNC machine with the indexing holes lined up, and we're going to cut it all out. And there's our roughing and our finishing and our cutout. And if we were able to do this, if the software could understand a top side and a bottom side, I would be able to turn this over and you would be able to see our pocketing tool path under here. But when we go to the CNC machine and you see each step come to life, I'm sure that it'll make a lot more sense. And so now this is going to fit nicely right on top of the other file, which was our box bottom. And so what we'll do now is we will save our underside tool path by itself, and there you get a pretty good look of that's the tool path of the underside, and then the model is facing the correct way. So we'll save the underside pocket first, wherever it is you save your tool paths. Then we'll come back and save our spoil board after we flip it tool path. And then we'll save the 3 tool paths that finish out our box top. It's letting me know that my tools are different numbers. So I'm using tool number 2 there, I'm using tool number 1 there, and I'm using tool number 1 there. And so this end mill should be tool number 2. My apologies. Calculate. And now it will allow me to save my 3 tool paths and save. And I will also save this file because it's my box top. And so now I have a box top file, a box bottom file, and the tool paths all set up and ready to go. And here we are at the CNC table. Couple of notes, couple of changes that I did. I had done the Vectric video before I knew what wood I had to use actually. So this is actually, instead of 1.5 inches thick, this is 1 7/8 inches thick, and I'm going 1 5/8 inches deep, leaving a 1/4 inch in the bottom of the box. And so the first set of video sequence that you'll see here is the hollowing out of the box. Now, something happened. I'm not sure what it was, but I stepped away from the machine for a moment, and when I came back, I noticed that my XY had jumped off axis. Could have been some kind of an electrical issue. I'm not really sure. I think the pool pump kicked on, and when it did, it caused some kind of a voltage change on the machine. Now, in the end, you'll see it didn't affect the way that anything fit, but you will notice as it machines the box here, you're going to see a little lip or a little ledge inside the box where it had cut. And so I reset the XY and continued, but I just wanted to point that out. In fact, I think it's coming up here, actually, that it was caught on video. If you have a look in the center of where that's cutting, you'll see right there that the Z seemed to dip a little bit lower than what it was. So anyway, you'll see it when this is cut out. You'll see how where the difference is, and I'll explain it to you then. But this is the hollowing out of the box, and then you'll see the profile cut out of the box, and then I'll come back and chat. And so here we are finishing up the profile cutout. There's one of the tabs, the tool releases, and there's our box bottom. And you can see inside here, I'll zoom the camera in here, and you can see where the XY axis, again, I don't know what happened there, but it certainly jumped off course. Luckily, it happened after the top was cut, or the portion that the top will slide into was cut. It ended up not affecting that, but I have no idea why it jumped off course there. But that's the box bottom. And let's go ahead and move on to the box top. Okay, so as you recall, we did the underside tool paths first. And so here we are drilling one of the index holes plus the underside pocket, with the buffalo facing, in this case, to the right. And so it will go through and do the underside tool paths first, as well as the indexing holes, and then we'll be back to talk about the next step. And so now as it finishes up the underside tool paths and finishes the last couple of indexing holes, we remove the underside, remove the workpiece from the CNC machine completely. And then what we'll do is we will run the indexing holes into the spoil board, and you'll notice that in this case there is one hole on the left hand side and two holes on the right hand side. Then now that the indexing holes have been drilled, we're going to come in here and put some 1/2-inch dowels as locator pins, so that we can then take our top workpiece and flip it horizontally so that the two holes that are on the left that we cut now are on the right hand side and line up perfectly with the indexing holes. And now we have the workpiece flipped over, and we can begin the tool paths on what will be the top side of our box. And so these next few video clips will be the roughing tool path first, followed by the finishing tool path, followed by the cutout tool path, and then we can look at the completed box. And I have sped up the footage so that you can, not stare aimlessly at a machine going back and forth. Yes, the finishing bit is a little bit burnt. I had done another project with some plaster of Paris. It doesn't appear that it is affecting the finish or the cutting of the finishing bit. But for the purist out there, yes, that bit needs to be replaced. I got it a little bit hot. But anyway, enjoy the finishing, roughing, and cutout, and then we'll come back and look at the finished box. And again, we've got to show the bad with the good. And right about here, the little leg pops off because there wasn't enough support underneath there as we had pocketed that out. Now, you'll see at the end with the finished box, it was a pretty clean break. I was able to glue it back together without very much distortion. And there it is. There's our finished Buffalo box. It's got some sanding, no doubt about it, right? But it's a neat little box. You could do it with just about any 3D model. You've got the bottom that we did. Definitely have some sanding. There's the little foot that ultimately I'll get glued back on there. But yeah, I'm really happy with how it turned out, and can't wait to do some more of these. I hope this process, although we had some challenges, no doubt about it, but this process of, milling the underside here first, and then the two-sided machining of then flipping it over and doing the top side, and then having that fit into the box to make a nice lid is something that can help you make some, pretty cool boxes. And so without a doubt, a very fun project, something I think that we could even make better. Definitely a couple of mistakes that hopefully my showing you the mistakes will help you when you do yours. Really fun projects to do. I've got some ideas for some other box tops. Again, just about any 3D relief model you could turn into, a little keepsake box. So just want to thank you for hanging in there. I know this was long. Really appreciate all of the support. I'm really working hard to try to get to that 10,000 subscriber mark. And so thank you again for all of your support. Thank you to Vectric. Thank you to Legacy CNC Woodworking for the idea. And really appreciate, again, everybody hanging in there to the end. So with that, we'll say have a great day. This is Work Against the Grain, and my name is Jeff.